Hello friends, myself Rajendra Mahajan presenting my video on statistics point moments. Let us define that term. Moment about mean. This is the rth moment of a variable about mean and it is obtained by formula is mu r is equals to 1 by n summation of fi multiplied by xi minus x bar brackets raised to r, where x bar is the mean. Then second, moment about any point A, the rth moment of a variable about any point A is obtained by, it is denoted by mu r dash is equals to 1 by n summation of fi multiplied by xi minus a bracket raised to r, where a is any point. That is the only difference. If we find moment about a point, we write xi minus a, and when we require to find moment about mean, we replace a by mean. We get xi minus x bar. In particular, we have the value of mu 0 is equals to mu 0 dash, and its value is equals to 1. That is the first result. Then next, mu 1 means mean about, moment about mean is 1 by n. Put r is equals to 1 in the formula, we get summation of fi xi minus x bar raised to 1, and its value is 0. Mu 1 is equals to 0, and mu 2, second moment, again about mean, it is 1 by n summation of fi multiplied by xi minus x bar bracket raised to 2, and this is nothing but sigma square, which we are calling as a variance. Already I have defined this term while discussing the standard deviation. If we take a square root of this, we get the standard deviation. Therefore, mu 2 is equals to 1 by n summation of fi multiplied by xi minus x bar bracket square. We are calling it as a sigma square, nothing but a variance. And if we take a square root, we get the standard deviation. Then relation between moment about mean and moment about any point, that is mu r and mu r dash. Mu 1 is equals to 0 always. Then mu 2 is given by mu 2 dash minus mu 1 dash square. If we see how to remember, the sum of the coefficient is 0. Coefficient of mu 2 dash is 1. Coefficient of mu 1 dash is minus 1. 1 minus 1 we get 0. Then third, mu 3 is equals to mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 times mu 1 dash cube. Therefore, once again I will repeat, mu 3 is equals to mu 3 dash minus 3 times mu 2 dash mu 1 dash plus 2 mu 1 dash cube. If we see the sum of the coefficient, 1 plus 2, 3, 3 minus 3, we get 0. And lastly, fourth result, mu4 is equals to mu4 dash minus 4 mu3 dash mu1 dash plus 6 times mu2 dash mu1 dash square minus 3 times mu1 dash raised to 4. Therefore, once again, 1 plus 6, 7. 7 minus 7, we get 0. That is 1. And second, the degree is increased by 1. First degree, second degree, first, second, third. Here first, second, third and fourth. Like this. Therefore, these are the relation between moment about mean and moment about any point. We can write moment about mean in terms of moment about any point with the help of these formulas. Next point is the coefficient of skewness. Skewness means when there is a lack of symmetry, then it is called as a skewed curve. Based on third moment, that coefficient of skewness based on third moment denoted by gamma as square root of beta 1, where the value of beta 1 is mu3 square divided by mu2 cube. And if that value of b1 is 0, then that distribution is symmetrical. Means curve is symmetrical. There is no skewness. If no skewness, then curve is symmetrical. Another important term, kurtosis. The degree of thickness of a distribution is measured by kurtosis, and it is given by or denoted by beta 2 as mu4, fourth moment divided by mu2 square. With the help of this value, we can find the degree of the thickness, and depending upon the value of that beta 2, we have 3 different types of curve. If we have the value of beta 2, means the value of kurtosis as 3, then the curve is called as a normal curve, as shown in the figure given below. This is the figure of that normal curve, where the value of that beta 2 is 3. Second case, if the value of beta 2 is less than 3, then that curve is called as platochortic, as shown below. Therefore, this is the figure of that platochortic, where the value of beta 2 is less than 3. And third case, if the value of beta 2 is greater than 3, then that curve is called as leptochortic, as shown in the figure. Therefore, this is the figure for that leptochortic curve. Therefore, 3 different types. The first one is normal curve, when the value of beta 2 is 3. If the value is less than 3, then it is a platochortic, as shown here in this figure. And third type, if the value is greater than 3, then that is called as leptochortic. Problem based on these moments I will discuss in my next video. Therefore, please like my video, share it, as well as subscribe to my channel. And to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.